Alrighty, in this video we're going to be looking at finding a specific term in a binomial expansion. These questions come up if you don't necessarily want the entire expansion and you just want a really specific term in that expansion. I'm going to show you how to do that in this video. Before we get into that, you need some prerequisite knowledge for this. First, you need to know what combinations are and how to use NCR, either the formula or it on a calculator. If you don't know how to do that, I'll put a link in the description so you can watch that video first and understand this part of the general expansion. And you also need to know what this summation notation is. You don't necessarily need to watch another video for that, I can tell you right now. But this weird looking E thing here, if you don't know, it means sum, so add up. And we're going to start when r is 0, and we're going to keep going until it reaches n. So if we had this expansion a plus b to the n, say n was 7, we would start at r equals 0, do this, and then we would iterate by 1, so make r go up to 1, and we'd do it again. And then we would do it again for r equals 2, and so on until r equals n, which in the hypothetical example was 7. So when r is 7, we'd do it for one last time, and then we'd be done. And once we got all of those individual values, we would add them all together, and that would be my expansion for a plus b to the power of 7 in that example. What we're going to do today, however, is not do the entire expansion. That's another video. What we're going to be looking at is finding a specific term in that expansion. And to do that, we are going to ignore this summation bit for now, and we're going to just be looking at this part for one specific value of r. It's that this r value in here that we're going to use one value of is going to be one less, I'll just write it in words, one less than the term number. Okay, so if I'm looking for the fifth term in some expansion, then this number is going to be one less than 5. It's going to be 4. And we're going to use that example up here. Determine the fourth term of the expansion 2x minus 2y all to the power of 6. Right, so we're going to use just this bit here. So we're going to set it up and say, well, first of all, n represents the power that we're raising it to. So we're going to say that this term is going to equal 6. And remember this part, 1 less than the term number. We're looking for the fourth term. So this r value is going to be 1 less than 4. It's going to be a 3. We then are going to have the first term in the binomial raised to the power of n minus r, which is the difference between these two. So we're going to multiply by 2x all to the power of 3, which is the difference between them. It's not this 3, it's just the difference. 6 minus 3 is 3. And then finally, we're going to have the second term raised to the power of this, which is also going to be 3. So we're going to have all of this, which is minus 2y, that's important, raised to the power of 3. And we're going to expand and simplify this. Now, on my calculator, which I'm going to bring up now, I'm going to be putting 6C3 in my calculator. And this is just a standard scientific calculator. If you have a graphics calculator, it'll be a slightly different process, but the functionality is still the combinations, which in my case, I'm going to put the n value first, 6, and then I go shift and divide. That gets me the NCR term, 6C3, which equals 20. So this first term is going to be 20. This second term, I have 2 cubed, which is 8. I have x cubed, which is just x cubed. Over here, I have minus 2 cubed, which in this case is going to be negative 8. And then I also have y cubed. While my calculator is still up, that's nice and handy. I'm going to do these multiplications, these values here. I'm going to first of all recognize that I have 2 positives and a negative. So my final answer is going to be negative. Start with that. And I'm going to do 8 times 8 times 20. So let's just go 8 squared times 20, which is 1280. So 1280. And then we have x cubed, y cubed. And just notice that the negative that was attached to the y cubed still is, it's just out the front of the entire term now. And that's my final answer to the fourth term of the expansion 2x minus 2y to the 6. The fourth term in that entire sequence is minus 1280 x cubed, y cubed. Okay, and the last thing I want to touch on, I'll get rid of this calculator so I have space here, is that I'm going to show you how to calculate 6C3 without a calculator. Say, for example, it's a tech-free exam. We have a formula for, and I have space here, NR is equal to n factorial divided by r factorial times n minus r factorial. And it's just on my screen, which is lovely. Now I can sub in my values. So I've got 6 and a 3. The numerator is going to be 6 factorial. My denominator is 3 factorial multiplied by 6 minus 3 factorial. I can simplify that now. It's going to be 6 factorial over 3 factorial times 3 factorial. And you can do a bit of hocus pocus here in your mind if you know how to do it really well, but I'm going to fully expand it out and simplify to really show you what's going on here. It's going to be a little bit messy because I'm running out of room, but you'll get my drift. So I'm going to represent this just here as 6 times 5 times 4 times 3 times 2 times 1 all over, now that's 6 factorial, is this 6 times 5 times 4 times 3 times 2 times 1. And the denominator is 3 times 2 times 1 times this 3 times 2 times 1. And the point is that I end up getting 3 times 2 times 1 here and here, so they cancel. And 3 times 2 times 1 is just 6, so I can cross that out with this 6, and all I'm left with is this expression here, 5 times 4, which is the 20 that we got when we put this in our calculator. So if you don't have access to a calculator, or you just want to speed up the process instead of having to rummage through your bag through the calculator, you can use this formula here, which is how you solve combinations by hand. When it gets to large numbers, it gets a little bit more difficult, but you still should be able to do it. Hopefully this video helped you find a specific term in a binomial expansion.